everyone. I am Choy from WSP. This is my pleasure can join today's GED talk for sharing my team experience of BIM application in geotechnical works for master planning and construction monitoring. Before my presentation, I would like to take this opportunity to thank the University of Hong Kong to their encouragement to BIM application, and also appreciate my team member for their involvement in this presentation. In the construction industry, BIM, Building Information Modeling, is commonly used in the architectural, structural, and building surface, but it also can apply in geotechnical works, no matter design or construction. In the following presentation, I would like to share the experience in building projects to show the beauty of the BIM in geotechnical works, which come out the improvement of design efficiency, cost reduction, enhancement of communication between engineers, contractor, and clients. In master planning, identification of site constraint and potential risk is crucial for the project development. If there is no BIM, engineer will summarize the site data by using plan, section after their desk study. Sometimes, client or stakeholder who have no engineering background may not be fully understanding what is the problem due to the constraint by only reading the plan, section, or summary. Another daily work example, develop the building master layout is time-consuming, especially the utilization of underground space in hillside area. I think we all have experience in cutting so many sections to facilitate client and architect during the master planning to estimate how many bulk excavation volume in different schemes. But this approach is not efficient and accurate. By using the BIM, the engineer can visualize the underground constraint, take good control of the design process, have clear understanding of ground behavior. For such commercial building projects as experience, the engineer used the BIM to let the client and project team have a full picture for the relationship between the original basement outline and underground constraint, such as how close to the existing tunnel and box culverts nearby, and then to develop stepped pavement approach to prevent adverse effects to the sensitive underground structures. Regarding the relation between building layout and site formation plan, we can optimize the cut and fill analysis process by merging the model of site topographic, ground profile, and different shape of building block. Use these institutional projects as experience. Architect and the engineer use the BIM to adjust the basement block to make the balance of cut and fill without compromising the overall development. Adjust the building block and retrieve the fill and cut data from the BIM is not difficult, and also reduce the resources in numbering of section cutting. Based on some ongoing projects use the BIM in master planning, here is the comparison of bulk excavation volume after several review in building and site formation layout. This also can reveal the rock excavation zone specifically in order to shorten the construction program as well as reduction of carbon emission. Step in the construction. One of the key beneficial of BIM for construction monitoring can let the engineer to track the site progress against the merged construction schedule instead of traditional program review from a piece of paper. This is the building construction site at Hong Kong U. The engineer and the contractor monitor the site progress with BIM. Trump LiDAR is used as one of the survey tools for monitor the excavation progress and compare the construction time frame in the model. Besides, the construction cost status is also timely updated into the model in other view for the project team and contractor consideration. BIM can also be used to simulate the step-by-step work sequence to optimize both design and construction. For example, it can use it to identify potential conflict between different elements of construction, such as the top-down construction method, soiling removal sequence in ERS work, etc. This simulation of construction method can do as a rehearsal, which allows the engineer and contractor to understand it more before the actual work progress. To wrap up, building information modeling will provide us more powerful tools for creating accurate, efficient, and cooperative design and construction monitoring. It's expected this will keep continuous and become more sophisticated. But what next? BIM is the tool in today. What we shall perform in the coming future? Shall AI or other innovative idea can lead your work with more automation? For example, is it possible to use AI for geological profile interpretation? Let's think about it and inspire our industry for future ready. Thanks all to listen my sharing today.